Our next session checks glasses. Jamie Lynch, fantastic. So Jamie, good to meet you, mate. Give it a shake of the hand. Thank you for that. Thank you for coming, mate. So we have how the Android framework monitors, processes, and triggers ANRs. Hopefully you're all set to go.
Yeah, can you hear me?
Take it away. Thank you for that. Yeah, you're coming through loud and clear, by the way.
Cool. Thanks for coming, everyone. So we're going to talk a little bit about how the Android framework processes ANRs and what it means for your game. So a little bit about myself. I'm a mobile architect at Embrace. And Embrace is a mobile observability and analytics company. And one of our focuses is on improving customers' ANR rate, as that can really affect your business. We take a fairly unique approach to ANR data gathering, which we're going to show you about now. So first off, I'd just like to say why we're here and why ANRs are a problem. So basically, this is from Google's Play Console for their ANR vitals. So effectively, if your app or game falls below a certain bad behavior threshold, that is, your app is freezing too much, you get punished by Google, and there's several consequences to that. So if you go above that bad behavior threshold, you get a lower Play Store ranking, so your game shows up much lower on search results, and you get less revenue and less traffic as a consequence. And that can all lead to various things, so less in-app purchases if you're selling money in your game, and just a general poor perception of your game. So there's a few things we think are stopping developers from solving ANRs because it's a really hard problem, particularly if you're using a game framework. But the two main reasons we see are there's limited data to solve ANRs, and when you do actually get the data you need to solve ANRs, there's a bit of a knowledge gap amongst developers on how to actually use that data in solving the problem. So I'll just go over the agenda of this talk briefly. So we're going to cover what the current ANR data is that's collected by Google, and what we think the limitations of that are. Secondly, we'll dive into how the Android OS itself actually triggers ANRs and what that means for your game. Thirdly, we'll talk about how the Android framework collects ANR data and how that is stored on the device. And then finally, we're going to talk a little bit about how ANRs can be solved. So let's cover that first item, what the current ANR data limitations are. We'll start firstly by going over the difference between ANRs and crashes. So most of you will be familiar with what crashes is effectively a coding error that immediately is going to kill your app. So in this example, maybe a user is going to go to the checkout, and there's some sort of bug, and that immediately terminates your process. And here's an example of an ANR, which is quite different, really, but it's treated the same, and we'll go into that in more detail later. So in an ANR example, a user might go to your checkout screen to purchase an item, and any one of these things could happen. You could have a slow network call, which blocks the main thread. You could have some third-party ad SDK, which is misbehaving. There's all sorts of things, really, which can slow down your main thread, but they all lead to the same thing, to an ANR, which can hurt your business. So a little bit about how Android actually provides the data for an ANR. So effectively, the Android OS just gathers a single stat trace at the end. So in our example here, we have an app running normally, then the user does something intensive, like maybe loading a new level in your game. During that period, the main thread is blocked, so the user can't interact with the device, so they're tapping it, but nothing happens. And if that goes on for about 5 seconds, Google will effectively capture a stat trace of the ANR. And at that point, a dialog shows up. A user can choose whether to kill your app or wait for it to resume. So in our opinion, this is kind of getting the the symptom and not understanding the root cause of the problem. Because really, with Google, you're getting a stack trace right at the end of the ANR, whereas really you want to see right at the start to see what triggered the main thread being blocked for so long. So let's go over our second item, how the ANRs are actually triggered. So we have a few, we basically dove into the Android source code and had a look at what the threshold for triggering an ANR is. And it's commonly held amongst Android developers and probably on the web that if you block the main thread for about 5 seconds, your app triggers an ANR, but that's not actually the case. We'll go through that in a bit more detail. But effectively, all the different components of the Android OS, like activity, service, broadcast receiver, they all have different thresholds for triggering an ANR from within each component. And we can talk a bit about what this means for your game. So the Android documentation on what an ANR is and how it's triggered is kind of lacking. But this diagram on the right effectively gives you a very high-level idea of how the Android OS schedules work in your app. So this applies even if you're in a game. So normally in a game, you would mainly only care about an activity, but you may have third-party ad SDKs or equivalent, which are using a service or a broadcast receiver. And effectively, the Android operating system is going to schedule work in each one of these 4 components. So if you've got a level, it will be in an activity on Android, and the Android OS will perform work whenever the user interacts with a interface, for example. And if that work builds up to take too long, it's effectively going to exceed a time threshold. And the Android OS monitors this on a background thread, just with a simple timer, and the threshold is different for each component. If that threshold is exceeded, we'll go over some examples of that shortly, then basically the Android framework calls ANR helper app not responding and kicks off triggering an ANR. So we'll just go through how an ANR is actually triggered for all the components briefly. So an activity, that's effectively some sort of screen where the user can interact with it. So that's probably what most people who are familiar with Android are familiar with. And the condition in which an ANR can be triggered in an activity is basically if input dispatching takes longer than 5 seconds. So there's an interesting little nuance there, that if your main thread is blocked for over 5 seconds and the user hasn't interacted with it, so they've not tapped it, then no ANR actually happens. If you think about this, it kind of makes sense. The user needs to be interacting with the app for the dialogue to actually show up, because otherwise you can kind of get away with it. Now we'll go over a service. So to recap, a service on Android is just something that can perform a long-running operation in the background. There's basically 2 places where an ANR can be triggered by the OS. You can have a foreground service, which doesn't call start foreground in under 10 seconds. So that's a bit longer than the activity. And you can also have a service which doesn't start or bind in under 20 seconds, or if your app is in the background, over 200 seconds. So it's quite interesting how the thresholds are a little different for this. We haven't been able to find a concrete answer for why that's the case, but we believe it's basically because the work's happening in the background and has a different CPU priority. Next, we'll cover a broadcast receiver. So broadcast receiver is a component that effectively responds to a system event. So you can register a receiver for many things. For example, when an SMS is received or when the connection changes, your game might want to know about that. And an ANR triggers in a broadcast receiver if the onReceive method takes longer than 10 seconds to complete. There's a couple of rules around this. So for instance, if the OS itself is booting, then that gets ignored, but by and large, they're kind of an edge case. Finally, we'll just briefly go over a content provider, which is probably less common as a source of ANRs, but is interesting nonetheless. So a content provider is effectively something that gives content to multiple applications on the device. So all devices have a content provider which gives you contact information, for example. And there's a very specific condition where an ANR will trigger if getProviderMIME the function, doesn't respond within 1 second. And there's actually a concrete recommendation from Google that you can effectively use getProviderMIME async method as that runs the task on a background thread. So you've seen there's 4 components, and they all kind of are interacting at the same time. So you may have multiple activities and dozens of services and broadcast receivers all competing for a main thread. And this leads to quite an interesting scenario where if you have maybe dozens of components, they're all competing for resources on the main thread, and they can effectively starve it, and your main thread is doing so much work that it kind of slows down and triggers an ANR. And in our example here, we've got a broadcast receiver responding to some event, which might be doing some sort of file input-output and is taking a long time. And then right at the end, we have an activity, which is trying to do some intensive work too, but it's taking much faster. And the important point here is in the broadcast receiver, even though that is taking the majority of the time, the ANR which you would get from Google is effectively just going to show the activity as the culprit, which can be really, really confusing. So we'll go over briefly how the Android framework actually collects ANR data now. So this diagram kind of summarizes the internals of the Android OS and how it captures a trace file, which is then used by Google in the Google Play console. So first off, the ANR threshold is exceeded. So your app's basically doing too much work. And then that calls into ANR helper app not responding within the Android OS. And that will basically cause a trace file to be collected. So that will contain loads of information like stat traces, thread traces, and process information. And after that's done, there's some further OS calls which basically alter the state of a process. But ultimately, we get to this point on the ANR dialog. The ANR dialog will pop up. The user gets to decide whether to kill your game or not, and the ANR contributes towards your Google Play console ANR rate. So we can go over briefly now how we can actually get better data to solve ANRs. So the first thing we can try is just collecting more data. So with Google and the Android OS, you effectively just get the last sample here. One of the approaches we've taken at Embrace is basically to start tracking samples much earlier when the main thread is blocked, so that you're able to get a better picture of what's happening over the whole duration of the ANR. And this kind of shows what that looks like at Embrace. So we effectively have a flame graph which shows you what is happening in an ANR. So this is for a JVM ANR, which so if you haven't seen a flame graph before, effectively the length of each component in the flame graph tells you approximately how frequent or how long each method took. So in this example, you can see there's something to do with shared preferences, which is taking quite a long time. And we feel this can be a really good way of surfacing information about ANRs, which can otherwise get hidden when you're just relying on a stat trace gathered right towards the end. So here's another example of that flame graph. So at Embrace, we effectively capture those ANRs in a single view. And we feel there's several benefits to that. We avoid having to group on things which might not particularly be appropriate for your app, and you can get the whole picture effectively and choose what you need to prioritize. So let's go over some takeaways from that. So we covered at the start that ANRs can effectively produce a really poor user experience. But beyond that, if you go above the Google Play ANR metric for Android Vitals, then it can directly impact your business and your game. You will not show up as a featured app in the Play Store, for example, and you won't show up in organic searches. So you tend to get far fewer players installing your app and therefore less revenue. Secondly, we've gone over how the Android OS itself actually collects information for ANRs, and it kind of treats them the same as a crash when it's completely different. So a crash is something which just terminates your application pretty much straight away, and the user impact is very clear. Whereas an ANR is more of a pernicious performance problem. It's hard to track down, and you really need a lot of data to be able to solve them. The Android framework monitors ANRs differently for each component. So we've gone through a little bit about what the different timings are and some of the reasons behind that. So you can approximately say that usually an ANR will happen if the user's interacting with your app for 5 seconds, but there are other conditions in which an ANR can trigger. For example, if you're doing too much work in a service in the background. And finally, we hope that we've shown you that having data basically helps you solve this problem and helps you better understand what ANRs are happening in your game. Thanks for listening. If you've got any questions, please let me know. We've got a couple of minutes. You can also send them to my email address.
How much what mediation solution you use impact ANRs? And what are your recommendations on this?
Sorry, I didn't quite hear that.
Was that?
I didn't quite hear the question.
Yeah. Okay. My question was about mediation solution and how much does it impact the one you choose, ANR rates?
Mm-hmm. So you're talking about third-party ad SDKs and that sort of thing. Is that correct? Yeah, we definitely found that when a customer installs the Embrace SDK into that app, that it's fairly common that a third-party ad SDK or some other third-party SDK will show up as one of the main contributors for ANRs. And just knowing that information is really valuable because you can then decide to switch it out if you need.